Thank you very much, Mr. Budi Gunadisadikin, for the welcoming speech. Ladies and gentlemen, with that, Gadjah Mada International Conference on Tropical Medicine 2022 has officially begun. We hope you will find the program we have lined up for you to be fruitful and engaging. Well, ladies and gentlemen, we already had some important remarks. Now we move to the first agenda today. It is the Symposium 3 about malaria. And this session will be moderated by our moderator, Mrs. Elsa Herdiana Murhandarwati, PhD from Universitas Gadjah Mada. Here it is the profile of Mrs. Elsa Herdiana. She has worked as a parasitology lecturer at Universitas Gadjah Mada, Faculty of Medicine, Public Health and Nursing since 1998. Her master education was earned at Universitas Gadjah Mada postgraduate program in tropical medicine, and doctoral education was completed in 2011 at Monash University, Melbourne, Australia, on the topic of malaria. Apart from teaching, she is actively conducting research at Center for Tropical Medicine in the Malaria and Neglected Tropical Diseases Division, and has published her works related to malaria and antidisease in national and international journals. Recently, she is the head of Parasitology Department of Faculty of Medicine, Public Health and Nursing, Universitas Gadjah Mada, and also in charge in the management of WHO TDR Implementation Research Special Master Program at the same institution. Well, ladies and gentlemen, I'd like to invite our moderator to lead the session. Please, Mrs. Elsa, the time is yours.
Good morning and welcome to the Symposium on Malaria. As we are all aware, malaria is one of the most severe public health problems worldwide. So far, our attention has been focused on the Plasmodium falciparum because of its ability to cause severe clinical manifestation and also death. However, this view has recently changed. Plasmodium vivax began to shift the dominance of the Plasmodium falciparum. For this, our first speaker, Professor Kevin Baird from Oxford Clinical Research Unit in Indonesia, will deliver his presentations titled Confronting the Steep Challenges in Diagnosis and Treatment of Plasmodium vivax. Ladies and gentlemen, eliminating malaria is a challenge and it's getting tougher and tougher, especially with the COVID pandemic. Therefore, our second speaker, Dr. Jeanne Rini from Mimika District Hospital and Pediatric Research Office, UGM, will present her talk, The COVID Threats Toward Malaria Elimination in 2030. And speaking about accelerating malaria elimination, we are looking forward for the presentation from our third speakers, Dr. Rintis Noviyanti from Pusat Riset Biologi Molekuler Eijkman BRIN, to share her knowledge and insight regarding the malaria vaccines. So without any further delay, let's start the symposium. Ladies and gentlemen, before our first speaker, Professor Kevin Baird, delivers the presentation, please allow us to show his profile, please, committee. So Professor Kevin Baird is the head of the Eijkman Oxford Clinical Research Unit in Jakarta, Indonesia, and Professor of Malariology. Good morning, Professor Kevin.
Good morning, Ibu.
Thank you. He's a professor at the Nuffield Department of Medicine, University of Oxford. He earned a BSc in microbiology, an MSc in biochemistry, and also PhD in medical zoology. He served 22 years on active duty in the U.S. Navy Medical Service Corps as a microbiologist, specializing in malaria prevention, control, treatment, epidemiology, and immunology research. He has long focused on Plasmodium vivax malaria, particularly on the problem of G6PD deficiency and primaquine therapy against relapse of that species. The unit in Jakarta undertakes clinical trials and therapies against relapse of Plasmodium vivax, principally in Indonesian soldiers, but also in Felix settings, in addition to laboratory and field studies of G6PD deficiency biochemistry, diagnostic, and epidemiology. Please, ladies and gentlemen, welcome to Prof. Kevin Baird. Please, Professor, for the next 20 minutes, the Zoom is yours. Thank you.
Thank you, Ibu Elsa. I'm trying to share my screen and I cannot. Can I be allowed to share screen, please? I'm trying to share and it says host disabled participant screen sharing.
Okay, let's wait, Professor.
Yes, thank you. Sorry. There we are. Okay, first of all, Ibu Elsa, thank you for that very kind introduction. And thanks very much to the organizers of this important conference. I'm very honored and privileged to be able to speak to this audience today. So thank you very much. You can read from the title of this presentation. I think it's directly relevant to the theme of this conference, global challenges to achieving One Health. And I'm specifically referring to the problem of Plasmodium vivax malaria. And today I'm going to be reviewing what may be news to many people in the audience today about new understanding about this infection that unfortunately, excuse me, makes it harder to combat this infection, specifically the diagnosis and treatment of Plasmodium vivax. Now, this is what we were all taught about this infection. This was a small and harmless presence globally in terms of health impacts. We called it the benign tertian malaria. It's one of those gentle non-falciparum malarias. We're taught that the parasitemia is self-limiting because of a preference for reticulocytes. This parasite plays no role whatsoever in the wrenching African malaria problem. And that's thanks to Duffy negativity and the inability of this parasite to invade those hosts, so we thought. And we also were taught that treating latent forms was unimportant, mostly because it's difficult, it's dangerous for G6PD deficient patients, and people get reinfected anyway. And after all, it's a harmless infection. All of this is wrong. None of this is true. Instead, Plasmodium vivax, I can paint a portrait that looks like this. If it's untreated or improperly treated, Plasmodium vivax will progress to severe and fatal illness. Most of the pathogenic biomass of this infection does not occur in the peripheral blood, as we've learned. Vascular spaces of the bone marrow, spleen, and liver. And this has far-reaching public health, laboratory, and clinical implications. Endemic P. vivax indeed occurs across sub-Saharan Africa, and treating latent forms of P. vivax is indeed essential to preserving the health and life of patients. And I assert that all of this is true. And as the bullet there says, I hope to persuade you of that in the few minutes that I have with you this morning. In terms of mortality associated with Plasmodium vivax, this is one of the toughest myths about Plasmodium vivax, this belief that it is a benign infection. It's simply not true. And here's a body of evidence from the World Health Organization. This was published a few years ago. And what you see here is a forest plot for a systematic review and meta-analysis of case fatality from Vivax compared to falciparum. And what we can see at a glance in studies from all over the endemic globe, that the mortality risk between the two species is approximately the same. Here is an important study from Indonesia. This is from the group Nick Douglas, Rini, Paulus, and others. Very large study, a clinical audit of malaria diagnosis and treatment outcomes at the hospital there in Mimika. You can see the data in this graphic. I'm going to crunch the numbers for you very quickly. Here's the case fatality rate for the two species. Here's the hospitalization rate for those two species. Here's the severe malaria rate among patients hospitalized with those diagnoses. You can see they're equitable. And here's the mortality rate between those two species. And again, we can see that the risk of death as an outcome after being hospitalized with severe malaria is equitable between falciparum and Vivax malarias. And so we can say with some confidence that Vivax is indeed as dangerous to hospitalized patients as falciparum. And this flies in the face of what we've all been taught, right? What we were taught stems largely from this body of knowledge. I'm summarizing here. This textbook, this textbook is considered the definitive book on malariology. It was published in 1949. It was written by the experts who lived through the malaria's first half of the 20th century. And what they said tended to be accepted as the gospel truths. That gave rise to this sentiment that the vast majority of deaths are caused by falciparum, while the other species cause a generally milder form of malaria that is rarely fatal. Now we know this is not true. S.F. Kitchen wrote the chapters on Plasmodium vivax malaria, and he characterized it as benign. And the reason he thought that really can be boiled down to a very simple set of observations. And that is, the numbers of parasites in peripheral blood define the degree of threat to the patient, and P. vivax almost never gathered there in threatening numbers. So there you have it. This remains axiomatic in modern contemporary malariology. We still believe this, that the presence and numbers of parasites in peripheral blood underpins the facts at our command that direct diagnosis, treatment, control, and understanding of epidemiology and pathogenesis of human malaria. And what I hope to convince you of this morning is that this is deeply problematic for Plasmodium vivax. This is the life cycle. Most of you will be familiar with it. This is life of P. vivax as we know it, a simple cycle involving a tissue phase, liver in humans, and a blood stage, which causes the acute disease, and of course, mosquito-borne transmission. Of course, we look to the peripheral blood for the diagnosis consistently, whether it's by microscopy, RDT, or nucleic acid testing. It's the peripheral blood that is the diagnosis of this infection, so that we can say fairly that the peripheral blood is a window through which we view malaria presence, prevalence, and scale of threat to the patient. So this metaphor of a brick wall with a window in it is I think, a fair one. And it has been that way from the very beginning. But we're beginning to understand, and I'm going to show you some data here quickly in a few minutes, that behind those bricks framing that window, we begin to see evidence that P. vivax also has an extravascular compartment in the bone marrow, the spleen, and the liver, so that schizogony is not limited to the bloodstream, but also occurs in extravascular spaces where expansion of that pathogenic biomass may occur. If we believe that parasite biomass drives pathogenesis, and we do, then we can also say that if that biomass is a relatively small proportion of the total, it may be inconsequential. What we see in peripheral blood captures the presence of scale of threat if it's a small proportion. If it's a large proportion, it's a very different story. It may be clinically consequential and unobserved. What we think of as a window may be more like a peephole. We're not seeing at all the whole picture of the Plasmodium vivax parasitism. This is a paper published a few years ago, a review, and in it is this data from a hospital in Sumba in Indonesia. And what you can see is scale of parasitemia on the x-axis and scale of illness in the bars in patients admitted with those two diagnoses. And you can see that they're conspicuously different in terms of the scale of parasitemia. So we have equal scales of illness, but unequal scales of parasitemia. And what may be going on in that graphic is this scenario where the P. falciparum biomass is resident largely in peripheral blood, but the P. vivax biomass is resident outside of the peripheral blood. That's the hypothesis. For this to be plausible, we need a biology that would explain this contrasting distribution. And it turns out that biology has been found and discovered in recent papers from Singapore and Thailand and Australia. Bottom line is this CD71 on the surface of a red blood cell is necessary for P. vivax to invade. That's important because CD71 is quite rare in peripheral blood and it's quite rich in erythropoietic tissues. So that what we can see is the setup by CD71 preference of the parasite to invade erythropoietic tissues and not reside in peripheral blood. If we look through the eyes of a P. vivax merozoite, we might look at peripheral blood and erythropoietic tissues as our own eyes view these two habitats. So that this is indeed plausible, but does it occur in living hosts? Here's an animal model where indeed it does. We can see in these graphics at a glance that most of the biomass of this infection in these experimental splenectomized animals is in the extravascular spaces of the bone marrow and the liver. But what about patients? Does this actually occur in human beings? Apparently it does. And I'm just showing you some numbers very quickly. I don't have much time, but what these numbers show is that in patients, most of the biomass that's causing severe disease in these patients is not seen in the peripheral blood. It's hidden in extravascular spaces. This is another paper from Brazil, more recent, more elegant techniques here, but showing fundamentally the same thing, that in patients who have high burdens of parasite as measured by Plasmodium lactate dehydrogenase, we see evidence of harm, and it's not reflected in the peripheral blood parasitemia. This is a very important paper published last year from Indonesia. This is from the group in Mimika, where they evaluated spleens taken from patients mostly for trauma, and showed that the biomass of parasites in these patients was overwhelmingly in the spleen and not in the peripheral blood. So this actually does occur in human patients. It turned out that the parasites were co-located in the spleen at anatomic sites where CD71 positive reticulocytes also occurred, where there was erythropoiesis occurring. So we have two very different parasitisms here, ladies and gentlemen, and this graphic illustrates that, where we have P. vivax, which is equipped to escape the vascular sinuses, where it finds almost nothing of what it requires, and it lodges itself in the bone marrow, spleen, and liver, where it finds the erythropoietic tissues it requires to expand its biomass. So it is in the deep organs, whereas in P. falciparum is largely trapped in the vascular sinuses, where it finds everything it needs. So this hypothetical seems to be true, that most of the biomass of this infection is indeed in the extravascular spaces of those deep organs and not in the peripheral blood. I want to talk about another form of Vivax malaria very quickly. This is not so obvious, but it's important, and it's pernicious Vivax. And I mean that in the literal sense of the word, having a harmful effect, especially in a gradual or subtle way. So this parasite, we know, the latent and subpatent stages of infection dominate over acute malaria. And we know that the detectable parasitemia may be absent, and yet the infection can cause serious illness. And the hypnozoite reservoir, I've not talked about that yet, but this is an important aspect of the harm that this parasite can cause. And here's how. This is experimental subjects, and you can see in the box, what is occurring is 7 mosquito bites in 7 people, causing 39 acute attacks over 20 months. That's a lot of malaria if that latent stage is not treated. We now know, thanks to many studies summarized in this meta-analysis and systematic review from the folks in Australia and Thailand, we can say with confidence now that the hypnozoite reservoir accounts for more than 80% of acute attacks in endemic zones. In other words, if you're seeing a patient with acute Vivax malaria, chances are it originated in that patient's liver rather than a new mosquito bite. Very important point there. This is data, again, from the group in Mimika, longitudinal cohort following small children for a year. And the graphics, I think, speak for themselves, that what we can see long-term is that P. vivax, a diagnosis of P. vivax, actually carries more mortality risk than Plasmodium falciparum in that cohort. Same group, same cohort, only all ages. You can see the adjusted odds ratio for Plasmodium falciparum after 14 days is elevated relative to P. vivax. Whereas on the other hand, if you go a year, you can see that the P. vivax mortality risk is almost twice that of P. falciparum. And this is why. That repeated cycle of infection, bone marrow dysfunction, this causes compensatory erythropoiesis in the spleen and liver. That allows the biomass to expand. And with relapses, again, and again, the disease gets progressively worse and far too often ends in death. So I'm summing up my last couple of slides here from a research perspective. The 2 points that I'd like you to remember is that the biomass of Plasmodium vivax is seated in extravascular spaces where it cannot be seen, measured, or linked to disease conditions. Second point, the absence or scale of parasites in peripheral blood is proof of neither in the case of Plasmodium vivax. And from a clinical perspective, simply to say that the biomass is often absent and not observed. And if you have patients with chronic anemia, thrombocytopenia, or pancytopenia with hepatosplenomegaly, think of Plasmodium vivax in the deep organs as the cause of that. If you resort to a bone marrow biopsy, maybe to rule out leukemia in such a patient, please consider Plasmodium vivax and actively rule it out from that specimen. And with that, I'm out of time, and I will close and say thank you to the chair, and thank you all for listening. I will be available later in the question and answer session. Thank you, Ibu Elsa.
Thank you, Prof. Kevin Baird. Thank you for sharing the important knowledge with us and raising the concern about the malaria Vivax. For the audience, if you have any question or comments, so please write the question in the chat box and write to whom the question is addressed. If there are some questions that cannot be answered yet, then we will discuss it and raise in the question and answer segment. Okay, thank you, Prof. Kevin Baird. Now we move to the next speakers. Our next speaker is Dr. Jeanne Rini Puspoprodjo, and she has recorded her presentation for us. Let me read her short bio. Yeah, okay. Thank you. So Dr. Jeanne Rini Puspoprodjo is a pediatrician and researcher at Mimika Research Facility and Mimika District Hospital in Timika, Papua, Indonesia. She also holds appointment with the Pediatric Research Office Department of Childhead Faculty of Medicine, Universitas Gadjah Mada. She earned her PhD at Menzies School of Health Research under the Australian Leadership Award Scholarship Share. She was a recipient of Wellcome Trust Research Training Fellowship in Tropical Medicines. She has worked as a mother and child health consultant for UNICEF, WHO Indonesia, and the Indonesian Ministry of Health. Her research interest is maternal and child health problem in developing worlds, focusing on disease epidemiology and program evaluation. Her current research focuses on the impact of malaria on pregnant women, infants, and children, and defines strategies of its treatment and prevention. Ladies and gentlemen, please welcome Dr. Jeanne Rini.
Hello, everyone. First of all, I'd like to thank the committee for inviting me to participate in this conference on tropical medicine. In this occasion, I would like to talk about the threat of COVID-19 to our efforts to achieve malaria elimination in 2030. So my talk will cover and discuss about the global trends of malaria and the global target for malaria elimination. I will provide evidences of the indirect effect of COVID-19 pandemic to malaria control program and morbidity and mortality from malaria. I would also discuss about efforts needs to be done to accelerate efforts to malaria elimination. So as you can see here in this graph, that the trends of malaria incidence and mortality since year 2000 to 2015 has been reduced significantly. But after 2015, the reductions looks stagnant. So this suggests that effective intervention alone is not sufficient to reduce malaria. It has to be accompanied by a good program management and planning. So in the global technical strategy that was developed to achieve malaria elimination, a framework was developed to inform countries about the need to also highlight or do efforts that can maximize impact of today's life-saving tools by ensuring universal access of malaria prevention, diagnosis, and treatment. And in places where the number of malaria is already low, efforts needs to be maintained and also transform malaria surveillance into a core intervention. There are also two supporting elements identified in this technical strategy, which is encouraging research to develop new tools or improve the existing tools. And the other supporting element is Also, we need to strengthening the enabling environment, such as political and financial commitments, involvement of multisectoral departments, and also capacity development for the staff that manage the program. So even before COVID-19 pandemics, there are several threats to malaria control, such as drug and insecticide resistance, the deletion of Plasmodium falciparum HRP2O3 proteins that can result in false negative RDT results, and also the spread of new invasive mosquitoes. Based on the SDGs report in 2022, we see that after the pandemic, we see disrupted essential health services. The majority of health services are disrupted, and also the severe reduction of essential healthcare, such as immunization, and the associated increased death from tuberculosis and malaria. So in year 2020, when the pandemic began, we see about 240 million malaria cases and more than 600,000 deaths in 85 endemic countries. So the majority of malaria are in Africa. And this map, we can see that the countries with red color are the countries that are still dealing with malaria. And with the COVID-19 pandemic, we see that resources are shifted to COVID-19 clinical care. So this is particularly important because in malaria endemic area, usually the health system is already fragile. So with the addition of COVID-19 clinical care, this will impact severely to malaria diagnosis and treatment program, as well as malaria prevention program. So with the restricted movements during COVID-19 and even lockdown, the delivery of malaria control program is halted or reduced. And also the supply chain is disrupted. In terms of the community are also afraid of coming to the health centers because afraid of contracting COVID-19 in health facilities. So evidence shows that during COVID-19 pandemic, we see a reduction in the delivery of the malaria prevention programs, such as insecticide-treated net distribution. So 60 countries has not completed ITN distribution, and IRS only completed in 67% of the countries. Seasonal malaria chemoprophylaxis only cover 60% of the population, and entomological monitoring activities is severely reduced. Clinical service disruptions also happened and shown in a survey in 11 countries in Africa, covering 1,500 service deliveries. So in this graph, you can see the alphabet represent countries, and the two graphs here represents when the pandemic began early, and then 6 months to 1 year after. As you can see quickly here, the green bar represent those health services without disruption. So during this COVID pandemic, we see clinical service disruption from 4% to 93%. And the health facilities which experience moderate to substantial disruption is less than 30%. So in terms of the delivery of malaria diagnosis and treatment, if we compare to the proportion of that delivers before the pandemic, in 2019, we see that in Q2 and Q3 of 2020, there is a severe reduction in the delivery of malaria diagnosis and treatment. As you can see here, the reduction is more profound in the Asia and less in Africa. But in Africa, 21% of facilities had drug stock out. During COVID pandemic, there is also the possibility that malaria is underdiagnosed because the symptoms are similar with COVID. So in order to provide countries the magnitude of the impact of the COVID-19 to coverage of an effective intervention program, a geospatial modeling analysis is carried out. Basically, they analyze 3 different scenarios in the delivery of anti-malarial drug and ITN distribution. And the level of coverage ranges from the moderate, which is 25% reduction, to severe, which is 75% reduction. As you can predict and imagine that with the reduced access, it's linear with the increased risk of clinical cases and deaths. You can see here in the graph that with the reduced access to malaria prevention, diagnosis, and treatment, there will be a 25% increase in clinical cases and 95% increase in deaths if there is a severe reduction. So this is an urgent call that we have to act now to increase the coverage of malaria intervention program. So we do see an increase in malaria morbidity and mortality during COVID-19 pandemic, with addition 14 million cases of malaria and 69,000 additional cases of deaths. So this is very important reminder for us to accelerate our efforts to achieve malaria elimination. Because we see, if we compare to our goal to eliminate malaria in 2030, now we are off track by 40% in the number of malaria as well as in the number of deaths. So efforts needs to be done. Yeah, there are some innovations, a good innovation that has been carried out in malaria endemic countries, such as here in Africa. The ITN distribution is still ongoing with PPE, and then malaria diagnosis and treatment are still ongoing by providing a protective barrier. But we need more strategy to improve our condition of malaria intervention program. So we need to accelerate coverage of the current tools to at least 80% in the context of COVID-19 pandemic. And learning from COVID-19, we have to transform our malaria surveillance as a key intervention. Innovations must be encouraged in vector control, diagnostic, drugs, vaccines, and etc., even community engagement, because we cannot do business as usual in this condition. And how do we do it? We need to again and again improve program management and planning, ensuring that supply chain and logistics are returned to normal. Information systems, communications, and community engagements needs to be reinforced while we are still maintaining best practice of COVID-19 prevention and control. So now we are dealing with COVID-19 and malaria in order to achieve our malaria elimination goal. And this is always important before or after COVID, that in order to achieve a high impact, there should be support from high-level commitments such as policy makers, politicians, and also a good managers and leadership in healthcare sectors, and also support from the community. So to sum up, in this presentation, we see that malaria remains a major public health problem. And then we see that malaria control program was disrupted by COVID-19 pandemic. And this result to our efforts to malaria elimination to reduce malaria morbidity or mortality are off track by 40% from 2020 target. This reminds us that we need to accelerate coverage of the current effective tools to at least 80% with more efforts and with hopefully with some innovations and with concerted efforts from political commitments, health sector and community, we can still achieve our goal of malaria elimination in 2030. Thank you.
Okay, thank you, Dr. Jeanne Rini. I'm sure that the audience are very interested with this topic. And this is, what's that? You raised the question, is 2030 target still achievable? Yeah. So we cannot do the business as usual. Okay, please, ladies and gentlemen, please have your question in the chat box. And after that, the key and answer segment, so we will discuss your questions. Okay, thank you very much, Dr. Jeanne Rini.
Thank you.
Okay, and now we move to the last presenters. Dr. Rintis Noviyanti. Good morning, Dr. Rintis.
Good morning, Dr. Elsa. Nice to see you again.
Nice to see you. So Dr. Rintis is very well-known malaria expert in the field of molecular biology. She will deliver her talk about malaria vaccines. But before her presentation, please let me read her profile. Okay, Dr. Rintis is the principal investigator and head of the Malaria Pathogenesis Laboratory Unit at the Eijkman Institute for Molecular Biology in Jakarta, Indonesia. Pusat Riset Biologi Molekuler Eijkman BRIN. Is it right, Dr. Rintis? Yeah.
Thank you.
Since 2011, she has involved in advancing malaria vaccine development under the coordinations of the Ministry of Research and Technology in the Republic of Indonesia. She was also a member of expert panels of Laboratory Working Group, the National Commission for Malaria Eradication, as part of Ministry of Health. Rintis graduated from a PhD in molecular biology of malaria parasites from the University of Melbourne in Australia, and has spent her career research in this field. So Dr. Rintis has many fellowships, many grants, and many studies, regarding the genetic diversity of malaria parasites in Indonesia. So please, Dr. Rintis, to start your presentations.
Thank you, Dr. Elsa. Let me share my slides. Okay. Very good morning to everyone here. First of all, I would like to thank for the invitations to this very important conference by the UGM. Today, I've been given a talk title about malaria vaccine. So I'm going to discuss about the global malaria status, malaria vaccine targets, and the current malaria vaccines in the pipelines, including RTSS, PFSPZ, and R21. According to the World Malaria Reports in 2021, there are approximately 241 million malaria cases in 85 malaria endemic countries. It is increasing from 227 million in 2019. And the malaria deaths reported was about 627, with an estimated of 47,000 deaths were due to service disruptions during COVID pandemic. The malaria status remained as high as around 250 million cases, with only slight reductions from the year 2000 to the year 2019. So if elimination is going to be achieved by 2030, there should be an interventions for this that include interventions on malaria vaccine, good anti-malaria treatment, indoor residual spray, for example, and vector control. Why malaria vaccine remains a complex matter? We all know that malaria poses a very complex life cycles that involves life cycles in mosquitoes and in human. The genome of malaria parasites, the Plasmodium species, has like about 22 megabases, base pairs of DNA in their genomes, and it has a lot of antigenic variations in them. So there are about approximately 5,000 genes that undergoes antigenic variations upon the immune challenge from the human host. We still don't know until now what is the correlates of protections in response to various antigenic types of malaria parasite of Plasmodium genome. This, of course, needs further study. This figure depicted some of the malaria vaccines available to date. There are vaccines that are made to target B and T cells to kill malaria parasites. They are made against different stages of malaria's life cycles. For example, circumsporozoite protein of Plasmodium falciparum, while targeting the sporozoites, the whole sporozoite antigens, and it is targeting mainly in the liver stage of parasite development. So with the various vaccine development to date, it should be theoretically possible to deploy this malaria vaccine to eventually eliminate malaria in the future. WHO has announced the malaria vaccine program that outlines the global strategy to accelerate research and development for malaria vaccines. So malaria vaccines should ideally be having like efficacy more than 75%, as stated by the WHO, and having 50% efficacy for severe malaria. The table on the left outlines the malaria vaccine outline available to date. There are not many malaria vaccines that reach the phase 3. It's only PF RTSS right now. And for the PF, SPZ, and R21 are the most top 3 vaccines, including the RTSS that has been going through their advanced stage of clinical trials. So RTSS is a subunit vaccine based on CSP of Plasmodium falciparum. This contains NANP repeats and CS protein, and having the T cell epitopes and the B cell surface antigens. So both RTSS, R21, they are all CSP based, and they are made as a VLP vaccines. While PF-SPZ scenario is actually consisted of whole sporozoites antigens that are injected into the human for vaccinations. This is the picture of the RTSS vaccines. It consists of the repeat antigens, NA and P repeats, that is connected or that is mixed with the T cell epitopes of the CS protein, and it is mixed with the hepatitis B surface antigens, co-expressed as a fusion protein, and then assembled as a mixed particle in Saccharomyces cerevisiae or yeast. And these are also made in as a VLP vaccine. The study of phase 3 randomized control trial of RTSS with ASO adjuvants has been done in African countries, including Kenya, Burkina Faso, Gabon, Ghana, Malawi, Mozambique, and Tanzania. This involves about 50,000 infants and young children. And the results was showed that about 39% of efficacy in young infants, and then about 29% prevented them from developing severe malaria. This is really helpful for many children and infants in Africa. And thus, the WHO has given the recommendations of this RTSS to be used as malaria vaccine. Another vaccine called R21 is made by the University of Oxford, was developed based on CS protein. This vaccine has a combination with matrix M adjuvant, and this is also a vaccine with the VLP forms. Publications in September 2022 in Lancet Infectious Disease on a clinical trial of R21 matrix M by the University of Oxford demonstrated the high vaccine efficacy that reaching about 77% against clinical malaria in children after 2 years of follow-up. This trial was conducted in Burkina Faso. The trial is done. The trial done in Nanoro, Burkina Faso, employing 450 children, were made into 3 groups. They're grouped into different groups here. Like group 1 consisted of about 150, and the same as group 2 and 3, and they receive different concentrations of combination between R21 and matrix M, where in the group 2, matrix M is slightly high, 50 microgram compared to the previous group 1. So the vaccination was done 3 times, like 4 weeks apart. And the control here was also used to examine the vaccine efficacy. With the primary outcomes of the 12-month trial, the group 1 and the group 2 showed high vaccine efficacy of 69% and 77% respectively, whereas group 3 control seems not to have a very good or very minimal vaccine efficacy here. The highest vaccine efficacy was seen in the combinations of 5 microgram of R21 and 50 microgram matrix M. This vaccine was given 3 doses, 4 weeks apart, and R21 has been proven safe and highly immunogenic. Comparing between the RTSS and R21, RTSS is produced in Saccharomyces cerevisiae, whereas in R21 it is in Hansenula. The RTSS was made in 1987, whereas quite recently the R21 was produced in 2020. The ratio between the CSP and the hepatitis B surface antigen is 1.4 ratio, where in the R21 is mostly expressing the CSP of the Plasmodium falciparum almost in the whole surface antigens of the VLP, and the adjuvant for the RTSS is AS01, while in the R21 is the M matrix. The efficacy is high in here, highest in the R21 M matrix, which reach about 77, while in the RTSS is roughly only 39. So another vaccine that has been undergoing many clinical trials is called PFS-BZVAC, produced by Scenaria in the US. The vaccine uses chemo-attenuated or irradiated whole sporozoites of 3D7 parasites. This vaccine produced aseptically purified, filed, cryopreserved, and met regulatory standards. There have been some modifications of this PFS-BZ vaccine to increase vaccine efficacy, and this is made by the company, which includes genetic modifications of the parasites to prolong their resting stage in the liver, given the anti-malaria drug-resistant chloroquine during the vaccination schedule. However, I'm not going to discuss more about these details because of the time constraint. In the clinical malaria human infection, or CHMI, done in multiple studies in US, Germany, Tanzania, and Mali, the PF-SPZ vaccine showed more than like 90% preventions of individuals being infected by PF. This is so far the highest vaccine efficacy in the CHMI. Dr. Pedro Alonso from the WHO director emphasized that if we wanted to eradicate malaria, we would need a vaccine with more than 95% efficacy. The result shows of the RTSS vaccine pilot implementations in roughly 900,000 infants and children in Ghana, Malawi, and Kenya have shown statistically significant reductions of about 21% of hospital admissions with a positive malaria test. This is not yet measuring efficacy against malaria infections. The vaccine seems to reduce disease symptoms, but the ability to reduce infections remains to be determined. Comparing between RTSS and PF-SPZ CHMI trials as shown here, RTSS has only having the less than 90% efficacy against non-variant PF in less than 3 months, whereas 100% efficacy was shown in PF-SPZ against highly variant PF. In adults in the field, with the RTSS, there's no significant protections at 3 to 4 months in the field trial in Africa, but there's no data currently in the pediatric trials. In PF-SPZ vaccine, it seems that there is a significant protection for 6 to 18 months in 5 different locations of clinical trial in Africa. Looking at different objectives of each vaccine's development, both RTSS and PF-SPZ are made to save life, reduce hospitalization, malaria elimination. Based on findings on vaccine efficacy, RTSS could reduce disease burden in children, while PF-SPZ vaccine could prevent infection, preventing transmission disease in general population, and has some potential to eliminate malaria. And some added applications for PF-SPZ is for travelers and pregnant women. RTSS vaccine is restricted to Plasmodium falciparum only, while PF-SPZ efficacy against Plasmodium vivax will be tested during the clinical trial conducted in Indonesia in soldiers deployed in Papua. So as the malaria vaccine going to be deployed in the population, a vaccine should ideally be made depending on the purpose. As an option to reduce malaria burden, a toolkit 1 consisting of bed nets, vector control, and a vaccine like RTSS would be good to be included in this plan. For the toolkit 2 to support malaria elimination, the combinations between mass drug administration, the vaccine like PF-SPZ could be another options. Currently, I would like to share you that we have a study in collaborations between the Faculty of Medicine, University of Indonesia, Eijkman, Indonesian armies, EOCRO, and Sanaria. We had a clinical trial in the Papua, where we followed the soldiers for 9 months after being vaccinated by 2 different vaccines called PF-SPZ and PF-SPZ-CVAC. The PI for this is Dr. Ernie Nelwan from Faculty of Medicine, University of Indonesia. So prior to deployment, the vaccination being given to the soldiers, the PF-SPZ vaccine were given 29 prior to departure, while the PFSPZ vaccine were given about like 2 months prior to the departure. And those vaccines were given 3 doses. The first one was given at day 1, 8, and 29, while the vaccine PFSPZ C stands for chloroquine, because during the vaccination, chloroquine was given every week, and the vaccination was done in day 1, 29, and 57. And after the vaccination, the soldiers are deployed in Papua, where they might be infected with both strains, Plasmodium falciparum and Plasmodium vivax. We will do the samples of their bloods every month to look at or to measure the vaccine efficacy. And after they finish their deployment, they will be followed up to 24 weeks to also assess the malaria status post-exposure. So the study is currently ongoing and will be resumed by the end of 2023. So the take-home message for the vaccine here to consider is the ideal vaccine should have an efficacy more than 75%. And this is basically the efficacy is affected by the human malaria status, especially the asymptomatic malaria. And in recent publication demonstrated that in fact, the asymptomatic individuals will respond less to the vaccination. Therefore, the vaccination could be affected by the population with the high asymptomatic individuals. And the vaccine status or vaccine efficacy is indeed also affected by the immune response, malaria protein in terms of the antigenic variations, and the adjuvants added into the mix of the vaccine. The malaria vaccines should ideally also be mass produced, because we have to deal with like more than 250 million individuals who are infected with malaria. And it has to be low cost and applicable for all malaria seasons. And if also to be designed for the travelers, it should have some high impact on vaccine efficacy. Also, finally, it's also have to be quite easy to be deployed. And what about the plan for malaria vaccine rollout in Indonesia? So we have 3 options right now. They are going to be like tested somewhere else, but in Indonesia, definitely for PFSPZ vaccine, we are still waiting whether or not anyone are interested for testing the R21 or even the RTSS, probably the Ministry of Health. And ideally, every vaccine here should help in reducing the burden of malaria in children in high malaria transmission area in Indonesia. One should also consider about the logistic, whether or not it requires the shipments of the dry shipper or liquid nitrogen chain, and the vaccine storage, whether it is in a room temperature, and how many vaccine given in the individuals, or how many doses, and what about the availability, whether or not the vaccines are present in a large quantity, and that all of the factors that actually should be included for considerations to choose which malaria vaccines are to be used, especially for clinical trial first in our country. And ideally also malaria vaccine for travelers, for example, for soldiers, has to be, considered for future use. In principle, the commitment for malaria eliminations required many parties, and we have to be working hard towards malaria elimination, and we have to support every, activities that are meant to be aimed for malaria eliminations at the end in Indonesia. Okay, I think that's all. Thank you very much for your attention. I would stop share.
Thank you, Dr. Rintis Noviyanti, for the very well said, interesting presentations. And I think that after this, there will be many questions for you. Yeah, okay. So in the chat box, we already have some questions. There are 4 questions that already answered. 2 questions for Prof. Kevin. First is about the serologic diagnostic for hepatozoites, that's already answered by Prof. Kevin Baird. So if you want to see the answer, you can go to the chat box. And also the other question is asking about the PLDH. In case there is any overlapping with the PLDH from other bacterial infections, that's also already answered by Prof. Kevin Baird. And there are 2 questions for Ibu Jeanne Rini Puspoprodjo from Mais Mahfudz, OHCC UGM, and Andani Leda Retnan UGM is already answered also. Now we have 2 questions that need answers from RD Lesvarian or RD. So please, Prof. Kevin Baird, would you like to answer these questions?
Ibu, I'm not seeing any questions in my chat. I'm not sure why not.
Okay.
Maybe you could read the question for me?
Okay, thank you. This is from Ardiles. Thank you for Prof. Kevin for the updates and great insight on Plasmodium Vivax. Until recently, to diagnose with Plasmodium, we still perform thin and thick blood smear due to its easy accessibility. However, since now we know that most of Vivax biomass stays in extravascular, do you have any suggestion on how to screen and or diagnose malaria Vivax in the rural area? Thank you very much. I think this is very important question, Prof. Kevin.
Yeah, it is a very important question, and thank you for it. This is a very serious problem, and it's one of the reasons I frankly don't believe the global burden estimates for Plasmodium Vivax seem to be so low, just a few million, compared to hundreds of million with Plasmodium falciparum. So we have to address this diagnostic problem if we're going to really understand the true burden and pathogenesis of this infection. In the short instance, I think that the diagnosis is going to be probably limited to hospital settings, laboratory settings, where plasmodial lactate dehydrogenase levels can be measured. I think that's an indication of infection in the absence of parasitemia. But more promising, there's some serological tests that are in development. I'm working with Rintis and others to optimize and validate a serological diagnosis of recent infection by Plasmodium Vivax. Now, that is not a direct diagnosis, but it is a diagnosis that I think would give a high index of suspicion that there may well be a parasite biomass unseen in the deep organs. And so the short answer to your question is the best hope is serological, and we're actively in pursuit of that kind of a serological diagnosis, which optimized, validated, would be as simple as an RDT, only it's antibody capture rather than antigen capture, which is how most RDTs work. I hope that answers the question.
Yeah. Okay. So thank you, Prof. Kevin. I think that's very clear. I have a practical question, Prof. Kevin. This is how to differentiate between the relapse and new infection for Plasmodium Vivax, Because it's always asking when we have like elimination assessment.
Another very good question, a tough one. That's one that we've struggled with for decades to try to sort out, looking at the genetics of reinfection versus relapse. And unfortunately, there is no clear test that easily distinguishes a relapse from a reinfection. It's complex reasons for that. Basically, the hypnozoite brings in a complexity to the genetics that makes it much harder to sort out than, for example, with P. falciparum, which is quite easy to distinguish a recrudescence from a reinfection. But with Vivax, that's not the case, and that's one we struggle with. And so currently, the only way to distinguish those is with epidemiological or clinical methods.
Okay, thank you, Prof. Kevin. For Dr. Jeanne Rini, I think you already answered the question also, but we have a question for you, Dr. Jeanne Rini. From your observation, Dr. Jeanne Rini, do you find any examples of innovation or good practices that have been carried out in Indonesia during COVID and proven to help the malaria program, Dr. Jeanne?
Thank you, Dr. Elsa. Yeah, so I can only speak about my experience and observation in Mimika in Papua. So during the COVID-19 pandemic, yes, we do have some heavy shift of, particularly at the district level, of the managers program. They are shifted to COVID-19 control program. But surprisingly, at the Puskesmas level, there is still efforts to maintain malaria diagnosis. So as you can see in my presentation, there is a picture. So they make a barrier. So they observe the COVID-19 prevention while still doing the malaria detection. With finger prick, as you see there. So yeah, that's one example of doing it. And also in terms of distributing ITN, we do have problem in the first 6 months of COVID-19 because people refuse to receive home visit by the district health. And on the other hand, there are some reduction of ITN delivery. But then after that, with while the health staff are more convinced that if you provide PPE, adequate PPE and physical distancing, then you can still deliver the ITN in the community. And it works quite well. So I think lesson learned from COVID-19, if we face another pandemic with a new disease, we should integrate those two diseases. I think it's easier to say than done. But yeah, so while maintaining the essential health services, we also have to manage this new disease by observing how to prevent and control the treatment. And at a clinical point of view, we need to also update the doctors to not to misdiagnose or mistreat between those two diseases. I hope this answers your question. Thank you.
Okay, yes, thank you, Dr. Jeanne Rini. So the point is to integrate our service with the other program, like in malaria, integrate with COVID, for example, something like that. Okay, and Dr. Rintis, there is no question for you, Dr. Rintis, but I have question for you. So as we know that I heard that for the military persons, they got the Malaria vaccines, right?
Yeah.
And then for the children, it's we prefer the RTSS vaccine. Is there any reasons behind that, Dr. Rintis?
Thank you, Dr. Elsa. I try to answer the questions. In fact, there is no age specifications for vaccines to be given either in children or in adults. Most study currently, like RTSS or R21, are started in the children or young individuals, like under the 18 years of age. However, RTSS has also been trialed in adults, similarly like in PFSPZ, but PFSPZ is mainly currently done in control human malaria infections, also recently in adults in soldiers. So I guess for the general purpose, the vaccine should be have like a age, there's no specific age for vaccine. So ideally that would be, highly likely be the case.
Okay, thank you, Dr. Yeah, thank you, Dr. Rintis. And for the vaccines that's already available, is it all for Plasmodium falciparum?
Currently, yes, but Malaria is also making the 5X Plasmodium 5X vaccine. Yeah, maybe Pak Kevin, can you help me with that?
I can try. Yeah, actually, the PFSPZ vaccine in the Indonesian soldiers, we actually hope, and we have scientific reasons to be hopeful, that PF vaccine may actually cross-protect against Plasmodium vivax. We know that in mouse malarias, Plasmodium burgeri and yoelii, that attenuated sporozoite vaccination indeed protects across species in that animal model. So one of the most exciting things about the trial Rintis outlined for us is it's the first look at the possibility of cross-species protection in the human malarias, and we should be able to see that in the soldier vaccine trial. And just a word on age. The RTSS is viewed as a vaccine for children in sub-Saharan Africa predominantly, mostly because it's a vaccine designed to prevent serious illness and death, prevent infection, right? Yeah. So in an African context, that makes terrific sense, to save African children's lives with a vaccine, even if it doesn't prevent infection. But with the sporozoite vaccines, the endpoint is indeed the prevention of not just illness and death, but infection writ large. So you are not infected at all. And that's why we think that the sporozoite vaccine technologies are especially relevant in elimination settings, where we're not trying to minimize a heavy burden of death. We're trying to eliminate the infection. So a vaccine that actually does that for us is of great interest, even at greater expense and trouble and liquid nitrogen and all that. So these are two very different technologies with two very different use cases.
Yes, thank you, Pak Kevin. Maybe I just need to add some points regarding the RTSS vaccine trial in adults. It has been done actually, but this doesn't. The result was not really significantly satisfying for this. So yes, I agree with Pak Kevin. At the moment, the RTSS is more targeted for children. Thank you.
Okay, thank you, Dr. Rintis. I would like to invite you to answer directly to the speakers. We still have 5 minutes for question and answer. Please raise your hand if you have questions. Okay. Oh, Josephine Dione. Okay, please, Josephine. Josephine, you like to ask to Prof. Kevin, Dr. Rini, or Dr. Rintis?
Okay, can you hear me?
Yes.
Okay, yeah, good morning. Thank you for the wonderful speech. I want to ask for Professor Kevin. I want to know as far as your research going, is there any sorry, is there any possibilities for malaria to be like have the ADE, the antibody dependent enhancement? So like when the infection occurs between the different type of the malaria, it causes the infection to be worsened, like we seen in the other infection disease like dengue. So I want to know if it like any possibilities for that, if some people infected with a different type of malaria, is it possible that the previous antibody for the first infection might cause the infection to become more severe? Do you have any experience in this also? Or yeah, I would like to know about that. Thank you very much.
All right, thank you, Josephine. A good question. I don't have any direct experience with that, but I think what we can do is look at the very large phase 3 trials for RTSS that were done in sub-Saharan Africa, involving tens of thousands of young children. Those children are exposed to other species of Plasmodium, including P. vivax and P. malariae and P. ovale. And what emerged from that trial is no evidence whatsoever of an exacerbated risk against any other malaria. There actually was a signal with meningococcal meningitis. Maybe it was worse, but a subsequent phase 3 and phase 4 trial showed that that was not true, that it did not exacerbate either any malaria, other malaria, or meningococcal meningitis. So very safe vaccines.
Okay, Josephine,
Yeah,
is
okay.
it answer your question?
Yeah, it's answered very clearly. Thank you very much, Professor.
Okay. So anyone else want to raise questions? So I think we have a lot of question and answer in these discussions directly and also in the chat box. So before I close this session, I would like to read my notes, the key message from each speaker. So the first from Professor Kevin Baird. And now we know that malaria Vivax is not benign anymore, is it right, Prof. Kevin? As this is also supported by many evidence. It is indeed as dangerous as Plasmodium falciparum, as it has hidden biomass extravascular. So we should pay more attention while suspect Plasmodium Vivax. The second speaker, Dr. Jeanne Rini, I take the notes from you that COVID-19 pandemic has disrupted the health service system, including malaria program. So the prevention, the service, the diagnosis, and also the treatment. So we need to accelerate the effort in order to achieve the malaria eliminations. And besides encourage innovation in every sector, the important lesson learned from COVID is to transform the surveillance into the key interventions. And the innovations is also to integrate the health program, the malaria program, into the other program like COVID program. From the Dr. Rintis, we know that to develop the malaria vaccine is very complex because the target is also very complex, many stadiums. Yeah, and for the vaccines, we think that some already available now, like the RTS, then R21, and also from Sanaria, PFSPZ vaccines. So the different vaccine, maybe they will have like a different target, and there are also 2 toolkits that we can choose. Yeah, what's that? Depend on what is our needs. So our options, something like that. So we also need to consider about and develop the vaccines, not only the target, but also the other like the logistic, the cost, etc. Something like that, Dr. Rintis. So that is the whole message that we can we can extract from the symposium. So hopefully this is useful for all of us, especially in supporting the malaria program, and particularly in Indonesia, because many audience here I see from Indonesia, coming from academicians, coming from the researchers, and also from the I think it's many here. Yeah. So thank you for the participations, ladies and gentlemen, and for our experts, Prof. Kevin Baird, from Dr. Jeanne Rini, and also Dr. Rintis. Thank you very much for joining this symposium, Malaria Symposium. Thank you very much. And I, Elsa Herdiana Murhandarwati, close this Malaria Symposium. Thank you. Terima kasih.